Support for today's Heat Treat Radio episode is provided by the Heat Treat Buyer's Guide. Use the free online directory to find Heat Treat service and product providers near you. Go to www.heattreatbuyersguide.com. And welcome to Heat Treat Radio. Whether you're listening to us or tuning in via video on heattreattoday.com/radio, we're glad to have you. We are continuing the Lunch and Learn series with members of the Heat Treat Today team. In this episode, we'll be hearing part 2 of what the heat treat doctor, Dan Herring, has to say about mill processes and production between aluminum and steel. The focus of this half will be about the products of steel and the reasons why producers choose the type and form of steel for their end product. The Heat Treat Today team includes Alyssa Bootsma, social media editor, Doug Glenn, publisher, Evelyn Thompson, assistant editor, Karen Ganser, senior editor and associate publisher, and myself. Let's take a listen.
When it comes to heat treating, the mill will do what we typically call basic operations. They will anneal the material, and if you'll recall, annealing is a softening operation, does other things, but we'll consider it for the purpose of this discussion a softening operation, so that the steel you order from the mill will be in a form that you can then manufacture a product from. You can machine it, you can drill it, you can bend it, and things of this nature. So there are various forms and various types of steel that can be ordered directly from the mill. So the mill typically does annealing operations and normalizing operations. The difference between annealing and normalizing is that annealing has a slower cooling rate than normalizing does. In the aluminum industry, we don't talk about normalizing, but we talk about homogenizing. Homogenizing is to aluminum what normalizing is to steel. Crude analogy, but it's true. But the idea is the fact, and the mill can do other processes. They can do other heat treatments. They can do specialized rolling and things of this nature to give you enhanced mechanical properties. In today's world, there's a lot of what we call custom or specialty mills that can manufacture very specialized products. There are mills that only make, well, not only, but primarily make pipe and tube. There are mills that make primarily wire. There are mills that make primarily strip. So there are some very custom or specialized mills out there. But in general, a mill will produce most of the type of products that we see or use in industry, or the steel for those products, and they will make it in a form that's usable for the end user and heat treat it to a condition where the end user can make a product with it. Now, obviously, once you make a product, you may then have to further heat treat that product, for example, to harden it or to give it certain characteristics that you need. And we'll talk about those things in later discussions about this. But what I did want to talk about is the types of steel that are produced by the mills. And I'll do this hopefully in a very, very broad context, but I think it'll make sense to everybody. And again, metallurgists aren't known too much for their creativity. So we start out with something called carbon steel, very original. There is low carbon steel, medium carbon steel, and high carbon steel. Low carbon steel has low carbon. Medium carbon steel has medium carbon, and a high carbon steel has high carbon. Now to be more serious, a low carbon steel typically has less than or equal to 0.3% carbon, or less than 0.3% carbon. A medium carbon steel has between 0.3% carbon and 0.6% carbon. And a high carbon steel is got greater than 0.6% carbon. An example of a medium carbon steel might be a 1050 or 1055 grade of steel. Those are commonly used for stampings, for example. So all of your seatbelt, both the tong and the receptacle, are made of a 1050, 1055 steel, and they're Aus-tempered to give them both strength and toughness, so that in an accident, the buckle won't shatter because it's hard but brittle, and it won't bend abnormally and therefore release because it has inherent toughness. So there are various things you do with these carbon steels in the heat treatment of them to enhance their properties. And then and carbon steels are used because they're low cost and they're produced in tremendous quantities. If you went to a hardware store and bought a piece of steel, it's very likely it will be a simple carbon steel. On the other hand, we also make alloy steels. And interestingly enough, there are low alloy steels, medium alloy steels, and guess what? High alloy steels. Again, metallurgists are very creative with their names. But the idea here is you get higher strength than a carbon steel, a little better wear resistance and toughness. You get a little better corrosion resistance, for example. You might even get some specialized electrical properties and things like this. But low carbon steel, just to go back to that for a minute, as I said, is produced in huge quantities. Examples are steel for buildings, steel for bridges, steels for ships. We learned our lesson, by the way, with the Titanic. We got the steel right this time. The problem with that steel, by the way, it was high in sulfur, which embrittled it, interestingly enough, in cold water. So when it hit the iceberg, the steel shattered because it was brittle, because it had too much sulfur. But we learned our lesson. There's also various construction materials. Anything from a wire that's used in fencing to automotive bodies to storage tanks to different devices. When you get into medium carbon steels, because they have a little better strength and a little better wear resistance, you can use them for forgings. You can use them for high strength castings. So in other words, if you're producing gears or axles or crankshafts, you might want to consider a medium carbon steel or seatbelt components, as we talked about. And then there's the family of high carbon steels. And again, they can be heat treated to give you extremely high hardness and strength. Now, they're obviously more expensive than medium carbon or low carbon steels, but when you're making knives and cutlery components, knives and scissors, for example, when you're making springs, when you're making tools and dies, that's another example. Railroad wheels are another example of something that might be made out of a high carbon steel. So as a result of this, you can get the type of product that your company is producing means that you're going to order a certain type of steel that you can use to make your product and give it the longevity or the life that your customers are expecting. One of the things about steel that differentiates it from aluminum, aluminum has a very good strength to weight ratio, but so again does the steel. But obviously the strength to weight ratio, the weight is specifically much more from that standpoint. But we can take steels that we produce from the mill and we can do processes like quench and temper them. And if we do that, we can make things like pressure vessels. We can make the bodies of submarines, for example. We can make various pressurized containers and things. So there's a lot of different things we can do with steels to enhance the products that we're producing. Besides just low carbon steel or carbon steels and alloy steels, we then can go into the family of stainless steels, for example. Most people think of stainless steels as being corrosion resistant. I'll warn you that not all stainless steels, however, are corrosion resistant. Some of them can corrode in certain medias or chemicals, if you will. But stainless steel is a good example of that is food processing, containers or piping or things that will hold food or food products. And again, we can make with stainless steels a variety of different products. So again, we can make different components for buildings, for example, or for trim components and things. So besides stainless steels, of course, we can make tool steels. Now, tool steels represent a very, very high alloy steel. The alloying content of tool steel is typically 30 to maybe 50% alloying elements. Molybdenum and vanadium and chromium and these types of materials. And as a result, we can make a lot of dies, and we can make a lot of cutting tools. We can make taps and other devices that are used to machine other metals, if you will. So tool steels have a lot of application. But there's a lot of specialty steels that are made by the mills as well. One example of that I like to talk about or think about is spring steels. Because you can make various things like knives and scraper blades, putty knives, for example, besides cutlery knives. You can make reeds for musical instruments, that the vibrating instruments in the orchestra, if you will. You can make springs, and you can make tape measures, tapes and rules and things of this nature out of these various spring steels, if you will. So they're depending on what your end use application is. There is the bottom line here is that whatever your end use application is, there's a particular type of steel that you should be using, and there's a form of that steel that you can use. And again, those steels can be produced by a variety of different processes. They can be forged, they can be rolled, hot and cold rolled again. And when I'm talking about hot rolling, I'm not talking about, I'm talking about temperatures in typically the 1800 degree Fahrenheit to 2300 degree Fahrenheit, 2300 degree Fahrenheit range. So when I talk about hot rolling, the metal is indeed hot, if you will. By the way, roughly iron will melt at around 2800 degrees Fahrenheit, just to give you a perspective on that, if you will. But the key to all this is that the form that's produced by the mill meets the needs of their customers and their customers' applications. And if you need plate, for example, they will produce plate in various sizes and thicknesses. By the way, just a quick note, and this is for all the heat treaters out there, be careful of the rolling direction in which the plate was produced. We have found that if you stamp or cut a component parts out of a plate with the rolling direction, or transverse or across the rolling direction, you can get vastly different properties out of the products. And it's amazing that you can get tremendous distortion differences from heat-treated products, depending on the rolling direction that if you're stamping or forming out of a plate, you're transverse or in line with the rolling direction. Most people don't even think of that. They take the plate, they move it onto into the stamping machine, and they could care less about the rolling direction. Then when the poor heat treater does his heat treating and distorts all the parts, the manufacturer says, "What's wrong?"
Yeah.
By the way, that little example took only 9 years of my life to solve one time. We had some what are called springs. They're the backing on a knife. When you open a knife blade, there's a member that it's attached to called a spring. Those springs were distorting horribly after being oil quenched in an integral quench furnace. It happened to be a conversation around the coffee machine where one of the guys made the comment that, it's really funny. We never had problems with distortion until we got that new stamping machine in. And lo and behold, in investigating it, the old machine took the plate in one direction. The new machine had to take the plate in a different direction and rotate it. End result.
We'll return in just a moment, but first, let me take 1 minute to offer you advice from our sponsor, the Heat Treat Buyer's Guide. Use this guide to find amazing North American heat treat providers and services, equipment, and related products. The super simple search tool allows you to browse by category or just search by a product or company name. The HeatTreatBuyersGuide.com helps to streamline your purchases and expenses so you can maintain excellent results in your heat treat shop. Go to www.HeatTreatBuyersGuide.com to start searching today. Again, that's www.HeatTreatBuyersGuide.com. Now, back to the episode.
So I guess for everybody listening, the key to this is that no matter what the material is that's being produced, we need to use it sometimes in its cast form. We need to use it sometime in its finished forms, which again can be bar and sheet and plate and wire and tube and things of this nature. And to get those shapes, we need to do things like hot and cold rolling. We need to do forging. We need to do operations like piercing to actually produce rings and things of this nature. So although I didn't go into all the details about that, there's a lot of information out there about it. I wanted to set the stage for it to say that it's the end use application by the customer that fuels the type of steel being produced and fuels the form in which the steel is produced. And then perhaps as a last comment, on my end anyway at this point, is the fact that mills are becoming, a mill is a business, just like anyone else's business. We're always looking for ways to cut costs, not cut corners, but reduce cost. And mills have found that in the old days, and the old days weren't necessarily the good old days, but in the old days, a mill made everything. They made all types of steel. They made all types of shapes and forms. But today, a lot of mills are saying it's not economical to produce that particular type of steel or that particular form of steel. So we'll leave that steel production to someone else, and we'll only concentrate on high volume production. It's very, if I still have the time, Doug, I'll do this. It's very interesting because when you're dealing with a heat of steel, when you're producing steel, a typical heat of steel, and people will probably correct me on this, but it's somewhere in the order of 330,000 pounds of steel. So if you're a small manufacturer and don't happen to need 330,000 pounds of steel, you have to go to a distributor and more or less maybe compromise a little bit to get the steel that you need. But the mills are producing large quantities of steel and very specialty steel grades in general today.
Right, right. So it's essentially specialization of labor. So it helps keep each individual mill's costs down, but yeah, it doesn't have the variety it used to. I was just gonna say, let's open it up just for questions real quick. I've got one if nobody else has one, but I hope somebody else has one. So fire away if you've got one.
Oh gosh, right when you said that, Doug, my question jumped out of my head. I had 3 questions, though none of the other ones I remember aren't that important. The one is I recently visited an old blast furnace in Pittsburgh, Cary Blast Furnace, and everybody should go if you're in the Pittsburgh area. But so some of this sounds familiar. The second thing I was wondering is just how high can the carbon percentages go in carbon steels? 0.6 plus, or wait, right? 0.6.
Yes, greater than 0.6%. And it's not uncommon for carbon in various types of steels to go over 1%. It typically can go in certain tool steels and things higher than that. But one of the things that differentiates a steel from a cast iron is the percentage of carbon in the material. And carbon over 2% is considered a cast iron as opposed to a steel. Steel has a carbon percentage from 0.008 all the way up to 2%. So that's a great question and something to be aware of. So when you buy a cast iron skillet, for example, you're getting a material that has greater than 2% carbon in it.
Okay, interesting.
Nice.
Interesting.
Another question I had. Oh, sorry, Doug. If you want
No,
to.
please go ahead. Go ahead, Bethany. Go ahead.
Well, another question I had is sort of more on the business end. If you know any of this, is with the high energy that it takes to process iron, I imagine that there have been efforts over time to try to reduce costs, reduce energy that's used via technologies and innovation. And especially right now with many people concerned with sustainability and those practices, are there ways that maybe even clients have influenced how businesses, iron manufacturers in the iron manufacturing world, in trying to keep those kind of environmental loads down? Do you know?
Yeah, that's a very intriguing question. I don't have all the facts and information on it, but I'll share a few things. As opposed to the production of aluminum, which is primarily using electricity, steel production uses typically gas, natural gas. There were in the old days oil-fired equipment and things of this nature, but today it's typically gas-fired furnaces and things of this nature. Now, I have to be careful when I say that because some of the steel refining methods, for example, the vacuum arc remelting furnaces and things of this nature, again, use carbon electrodes and use electricity, if you will, in the process. But essentially, what they're trying to do is they're trying to, for example, capture waste heat and reuse it to preheat different materials and processes and things of this nature. And they're using methods that are trying to make the overall equipment more energy friendly, if you will, more better insulations, better fit of components. In the old days, they didn't care too much about that. If we've got heat pouring out into the shop, we don't care. Today, we really care about those things. So, but steel making is a very, again, for a different reason than aluminum, it's a very energy intensive process. So it uses a lot of energy to produce steel. I'll make a quick comment also, and I'm not saying this especially from anyone internationally who happens to be listening into this, I'm not saying this as a America only comment, if you will, but in 1900, the largest industry, the largest company in the US, anyone want to take a guess? Was US Steel. Okay, United States Steel was the #1 most profitable company in the country. And if you think about it, throughout the what would be the 20th century, throughout the 20th century, steel and steel production has fueled, if you will, the American economy. We've since transitioned to other more angelic materials, if I can use that phrase. I won't define it. However, who do you think produces over 50% of the world's steel today? Anyone want to guess? No. China, absolutely. And where is the manufacturing growth taking place? So the production of aluminum, the production of steel fuels manufacturing is my message here. So yes, there are environmental consequences, but I often use the phrase, and again, this is not intended to be insultive to any one country, but for all the recycling, for all the energy saving, for all the environmental progress we can make in the United States, if we could reduce coal consumption in China, it would produce, and India, of course, it would have major impact on the environment. So, and that's, not having 100-year-old steel mills like we have here in the US will go a long way, if you will, to doing that.
Yeah. Anybody else? Another quick question?
Well, I've got one other comment, Doug, real quick also. We didn't cover a lot of additive manufacturing today. I think we should save that subject for a subject unto itself. I've got a lot to say on it, but we can't cover it here.
Yeah, that's good. I'm going to give you 30 seconds, Dan, to answer one more question. Okay, here's the question. Aluminum doesn't rust. Most steels do. Why is that?
In simple terms, because aluminum reforms an aluminum oxide on the surface. And that oxide is impenetrable, virtually, to further oxidation. Whereas iron produces an iron oxide on the surface in the form of rust. It flakes off and you can reoxidize the surface. Now there are steels, Cor-Ten is an example, self-rusting steels that once they rust, they don't reoxidize. But that's the basic difference, Doug, between
Gotcha.
them.
Perfect. All right, guys. Thank you very much, Dan. Appreciate it. We're going to get you on deck for another one here pretty soon on some other topics, but appreciate your expertise.
Always a pleasure. And as I said, I've reduced 3,000 pages into 30 minutes. So hopefully people that are interested will read up more on these processes.
Yeah, appreciate it. Thank you.
Okay. Thanks, everybody.
We hope you enjoyed listening to today's episode with Dan Herring. Heat Treat Radio is on Spotify, Apple Podcasts, SoundCloud, iHeartRadio, Podbean, and the website www.heattreattoday.com/radio. If you'd like to get in contact with Dan, head over to www.heat-treat-doctor.com, or you can email him at dherring@heat-treat-doctor.com, or email me and I can put you in touch. My email is bethany@heattreattoday.com. As always, if you have a new or interesting idea that you want to hear discussed on Heat Treat Radio, let me know. Also, if you'd like to sponsor a future episode, let me know at bethany@heattreattoday.com. Heat Treat Radio is just one of the ways that Heat Treat Today tries to help you get the information you need to make good decisions. If you like what you heard, explore the e-newsletters, ebooks, social media groups, and more on heattreattoday.com. And be on the lookout for more Lunch and Learn episodes or other technical conversations on heattreattoday.com/radio. Heat Treat Radio would like to thank the Heat Treat Buyer's Guide for sponsoring this episode. Use the free online directory to find Heat Treat service and product providers near you. Go to www.heattreatbuyersguide.com. This and every other episode of Heat Treat Radio is the sole property of Heat Treat Today and may not be reproduced in part or in whole without advance written permission from Heat Treat Today. And I'm Bethany Leone. Thank you for listening.